Edexcel Decision 1, Critical Path Analysis 3, Resource Histograms and Scheduling, Interpreting and Modifying Schedules. So it's not often that an unlimited number of resources are available, so it's likely schedules will need to be modified to take this into account. When the number of available workers is fewer than the minimum required, the project will be delayed. When modifying a schedule, special care is needed to ensure the dependencies of each network are still adhered to, and this is something that is often forgotten. So to recap, we must assume that each activity is completed by a single worker. Once an activity has started, it needs to be completed by that worker. And once an activity has been completed, the worker is immediately available to start another. So we should always try to use the first available worker. And if there are a choice of tasks, we must assign the one with the lowest value for its latest finish time. Okay, so we're going to look at this activity network, and we're going to look at drawing a scheduling diagram for it. Before we do though, we're just going to recap on a few things. Firstly, what does this dotted line represent? So it represents a dummy activity. And it's required because G is dependent on D, but I is dependent on both F and D. So the dummy activity is required to be able to draw the diagram. So how many days does this project take to complete? It takes 30 days. What is the critical path? So the critical path is made up of the activities that can't be delayed. So that's A, C, F, I and J. And what is the minimum number of workers required to complete the project on time? So we know that to find the lower bound for the minimum number of workers, we must add up all the durations of the activities. So the total duration time is 65 in this case. And then we divide it by the project length, so that's 30, which is 2.16. So we know that the lower bound for the number of workers is 3 workers. So we know that in order for this project to finish on time, we require at least 3 workers. So we only have 2 workers available, and we want to construct a scheduling diagram to find the minimum length of time required to complete the project using these 2 workers. So we know the project will be delayed, but what we want to do is minimize this delay. So what we don't do this time is we do not assign the critical path to any one worker. We must assign activities individually as we go along the network. Okay, so the first one we're going to assign is activity A. We're going to assign that to worker 1 and activity B to worker 2. I'm going to tick off my activities as I go along so that I don't forget to include any activities in my scheduling diagram. So the first worker available is worker 2, so I'm going to assign activity E. I can't assign activity C or D because A has not finished yet. So now worker 1 can do either C or D, and to decide which activities we do first, we look at the latest finish times, and C has a lower latest finish time of 17, so we assign activity C. So worker 2 can now do activity D, and worker 1 is now assigned activity F. Worker 1 can't be assigned activity G because G is dependent on D. So worker 2 is assigned activity G. And now worker 1 has a choice of activity I, H or K. Now we always assign the activity with the lowest latest finish time. So that is either I or H because it has a finish time of 26. So out of I or H, we will now have to do it by inspection to see which one creates the smallest delay. So if we were to assign activity I, so that has a duration of 5, so I would go here. Then worker 2 would do activity H with a duration of 8, so that's up to 31. And then worker 1 would have to do activity K. Do J because J is dependent on H. So worker 1 is the first available, but the only activity left is activity J, and J is dependent on H, so J can't be done by worker 1 until day 31. So activity J is day 31 and it finishes on day 35, delaying the project by 5 days. So then we look at what would happen if we had assigned activity H to worker 1 and activity I to worker 2. So if we had assigned activity H to worker 1 instead, and then I to worker 2, I'm going to tick them off as I go this time, then worker 2 is available first and would do activity K, and worker 1 can now do activity J, and the whole project this time finishes on day 33, and this is only a 3-day delay. So out of the two options, this is the preferred option as it delays the project by 3 days instead of 4. So when drawing a scheduling diagram with a limited number of workers, we do not assign the critical path to any one worker. We assign activities one by one as we go through the network. Don't forget, we must always check that the dependency conditions are satisfied. So as we can see, both these workers are busy right up to day 32 for worker 2 and the end of day 33 for worker 1. If any of these activities are delayed, then the project will be delayed even further. So in reality, this network could relate to a building site and a building firm. Now, if this project were delayed by 3 days, this could have huge implications for the firm. The firm might have to pay a fine because perhaps originally the firm said it would finish in 30 days. They would need to pay workers extra if they're on a daily rate. Perhaps the company would lose money if they're getting paid for the job because they may have quoted for the job lot rather than how long it takes. So it all depends on the situation as to whether it would be beneficial for the company to have employed an extra worker to get the job done on time, or whether the company is happy to just have 2 workers working every single day and delaying the project by 3 days. So scheduling diagrams are really important in making these decisions. So this concludes the section on resource histograms and scheduling.